Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 5, Section 2, Relations and Functions. So starting with a few definitions. A relation is any set of ordered pairs. The operative word here, the important word, is pairs. In order for something to be a function, or a relation rather, like if I told you that B is the set of ordered pairs 1, 0, 3, 7, and 4, negative 1, 4. These are pairs, so this is a relation. If these would have been given to you in groups of 3 or 4 or 5, no, not a relation. So a relation is a set of ordered pairs. Now, a function is a special kind of relation where each x has only one y. And we kind of made a joke out of this in class because these jokes help us remember things. That each husband only has one wife, because the word wife and y sort of sound the same. So each x can only have one y. Now, in my joke, in the function definition, the vice versa is not true. In real life it is, but in this definition of functions, a y can map to more than one x, and that's okay. But each x can only map to one y. And we'll look at that in a picture here in just a moment with some mapping diagrams. The next term is domain. This is hugely important. We'll be talking about this a lot because we're looking at different graphs, and the graphs only exist where the domain and range are. So we'll have to make sure we know where they don't exist, where they cannot be graphed. So for today, we're just going to start our discussion and our understanding of the words domain and range. Here, the domain is the input. It's the x's that go in. Remember when we had like y equals 3x plus 1. The input, the x, the domain is what number goes in here for x. And then let's say we had a domain that x is supposed to be equal to 2. So you put the 2 in there, it becomes 3 times 2 plus 1. So 6 plus 1, y is 7. So this 2, this is the input, this is the x coordinate. The y, the range, is the output. So an ordered pair that would work for this equation is 2, 7. Because 2 was the x, that was the input. Y is the result of the math that we got the answer from putting the 2 in. And so the y is the output. So you need to find a way to remember that the domain is all the x's and the range is all the y's. Example 1, part A says, to state the domain and range of this relation. So I'll use a capital D for domain. We need to list all the elements in the domain. Remember that the domain is all the x's, the range is all the y's. So we have here an xy, 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 and xy. So a list of all the x's, the domain, -3, 2, so I pulled out this -3 and this 2. I don't need to list 2 again in the domain. It wouldn't be wrong if you did, but it's not needed. And then 4 is also one of the x values. The range now is all the y values. So 5, 2, 4, and -1 in no particular order. Now part B asks us to make a mapping diagram. So we draw 2 circles. This circle is the x, represents the domain of this relation. This circle represents the y. So we're going to put the x values in the domain circle, and we're going to put the y values in the range circle. And now when we draw an arrow, we want to make sure we are pointing the arrow in the right direction. This x, this -3, is mapping over to this 5. So the arrow points to the 5. This 2 maps to 2, and this 2 maps to 4, and this 4 maps to negative 1. So that's a mapping diagram with the arrows. Now, this final question in this example, is relation A also a function? So just to remind you, each x can only map to one y. So let's look if that is indeed the case. All right, negative 3 is okay, but look at this 2 here. It maps to a 2, and it also maps to a 4. So the answer to this would be no, it's not a function, because the 2 maps to 2 different y's. All right, take a minute now and look at these 2 examples and ask yourself, is it a function? Just remember that each x can only have one y. So if you took a look at these, I hope you see that example 1, we'd have to say no, this is not a function because of the 1. The 1 maps to a 2, and it also maps to a 3. Over here in example 2, does each x only have one y? And we would say yes. It's okay that 9 maps to 3 and 2 also maps to 3. The 3 isn't a problem. But since each x only has one y, we would say yes, this is a function. The last part of this section is to discuss function notation. So this is really a reading lesson about reading algebra. Sometimes letters are not variables. They're used to name a function. When we use f for g or h or anything, and we put it like this, if we say f and then put in parentheses the x, this is read f of x. This f is not a variable, it's a name, like George or Bob, and it's saying it tells us what to do with the x. Oh, I don't know, we could have this f meaning that you square the x and add 1. So this x can be anything. We could be asked to find f of 3, meaning we put 3 in for x. So we'd have 3 squared plus 1, so that's 10, where the input is 3, the output is 10. This f is just the name of this function and tells us what to do with the x, or in this case, the number 3. So what kind of freaks people out sometimes is that f of x and y are interchangeable. Now, we don't have an f of x button on our calc, so it's handy for when we need to enter things. When I say interchangeable, I mean that we could take out this f of x and put in the letter y. So f of x equals x squared plus 1 and y equals x squared plus 1 are the exact same thing. Writing it like this is nice because then we can enter x squared plus 1 on our calculator and graph the parabola very nicely. So just a reading lesson about function notation. When we talk about independent variable, this helps us when we're setting up scatter plots because we always put the independent along the x-axis and we put the dependent variable along the y-axis. So if I had a picture of that, this would always be the independent variable, and this is always the dependent variable up on the y. And in your assignment, you're asked to determine which is which, and so we can discuss these a little bit. You learn them a bit by discussion. So some examples of independent and dependent just for discussion here. We could go back to my example about the faster you drive, the worse your mileage. So the independent variable is the one you have control over usually, like how far are you going to push the gas pedal down? How fast are you going to drive is the independent. And then your gas mileage would depend on that, so that's the dependent. So like I said, we'll have to discuss those in class if there's questions, and you'll just learn those as we go along. But please do ask when you're setting up a scatter plot and make sure you have the independent variable. We need to enter that in the X category into our calculators. So now I think you have all the knowledge you need to do section 5.2, so have fun with math.